Go and open your book to page 344. This lesson is on how to use synthetic division to divide the polynomial. So let's go over the division again. So if you look at the example, so you have 2x cubed minus 9x squared plus 14x minus 8, and you divide by x minus 3. So again, if you go through the regular division, so look at this one over here. So you're going to have a 2x squared, and so when you multiply, you get 2x cubed minus 6x squared, and then you draw the line and you subtract, and so you end up with negative 3x squared. You drop the next term, and then again you divide, you're going to get minus 3x. So when you multiply, you get minus 3x squared plus 9x. Draw the line, parentheses, subtract. Okay? And then, so this cancels out, so you're going to get 5x, and drop the next term, minus 8. So this one you're going to get plus 5. Okay? So you're going to get 5x minus 15. Okay, parentheses, subtract, and you're going to end up with 7. Right? So this is a regular division. Okay? But again, it's very cumbersome. So you're going to do something called a synthetic division. It's going to be very similar to this. The synthetic division, the way it works is this. Okay? Instead of writing up everything, it's like a shorthand. You only write down the numbers, and you don't write all the x, because all the x is going to get all canceled out anyway, right? So this is the way it works. Okay? So you see this over here. So when you're doing the division, right, you just write down the coefficient. You see the 2, the negative 9, the plus 14, and the negative 8, right? So when you write your synthetic division, you just write the coefficient. So you write 2, negative 9, 14, and negative 8. Okay? And you're going to do the upside down division. Okay? And you see this number over here. You see the x minus 3. I'm going to just use positive 3. I'm going to do the opposite. Okay? I'm going to do the opposite. Because if I take this way, I have to multiply and subtract. And you know how difficult it is to subtract, right? It's easy to make a mistake, right? So I'm going to do the opposite. So I'm going to take the opposite. So instead of subtraction, I will do the addition, right? Addition is much easier to do, right? Okay? So now you're ready to, so notice this number over here. See the 2, right? You just drop this number, okay? So you drop the number, okay? So now when you multiply, okay, you see this 6 over here. Now remember, everything is going to be opposite, right? So everything is going to be opposite now. So you see this, so instead of negative 6, this is going to be a 6, right? Well, where this 6 came from? Well, it's going to come from here 3 times. So you multiply. So you drop, multiply, you put it over here. Okay? Now because we take the opposite, instead of subtract, we're going to add, right? It's much easier to add than subtract. So when you add this, you're going to get what? Negative 3. Okay? And that's where this came from, right? See the negative 3 and this negative 3 over here. See over here? See how the number come out? So it's exactly the same thing. The difference is that you don't write all the x cubed, x squared, x. Okay? You drop all that. You just focus on the number. Okay? And also, instead of writing the negative 3, you take the opposite. So that way you add instead of subtract, because it's much easier to add than subtract. Okay? Okay, so again, notice again, you see the subtract, right? Okay, so now you multiply, you're going to get 3 times, so again, you multiply, you put up here, right? So you multiply, you get negative 9. Again, if you notice where the negative 9 came from, see over here? See this? Remember, everything's opposite, right? Everything's all opposite. Remember what I said, right? Okay? And so when you add, you get what? You get 5, right? And notice you're going to get this 5 over here. Okay? You're going to get this 5. Okay, so again, see the 3, negative 2, negative 3, 5. Right? Everybody see that? 2, negative 3, 5. Okay? Okay? And so again, you multiply, you're going to get this 15 over here. Okay? And then when you when you add, you're going to get positive 7. Okay? I'm going to use a different color. You're going to get positive 7. Okay? Now, put a 9 right over here. Okay? So what about this 7? Well, if you compare this over here, see the 7, that's your remainder, right? See that? And where this 15 came from? Well, this 15 is right over here. Remember, everything's all opposite, right? See this 15 over here? So notice how you get from here to here. They're the same thing. The only difference is, again, you basically you get rid of all the x, right? See how this compress, right? And so your answer would be, so your final answer would be, again, see over here, see the 2, this is going to be 2x squared, right? See over here, okay? All right, so you're going to get 2x squared minus 3x, see over here, plus 5. And this is your remainder, okay? So your remainder would be plus 7 over x minus 3, right? That's your remainder. So this is your remainder. Okay. Now, how do you know how do you know this is x squared? Well, this is x cubed divided by x, you're going to get x squared. Or you can start counting, right? This is x to the 0. This is the remainder. This would be the x to the 0 power, x to the 1 power, x to the 2 power, right? You can just count it. And so this is called synthetic deviation. So it's much quicker. Okay. So that's going to do a couple more examples. But one thing, remember, you don't get something for nothing, right? There's a limitation to this. Okay. In order to use synthetic deviation, you can have a number in front of the x. You must have x plus a number or x minus a number. Okay. Okay, so let's go and do example 1. So let's go to example 1. Okay, so you have an x4 plus 5x3 minus 9x plus 6, and you want to divide it by x plus 2. Okay, so again, so write down the coefficient. So 1, 5. Now notice there's no x squared, right? So you need to put a 0 for the x squared. Okay, see the 0 for the x squared. So you have to pay attention to that. Okay, on a test, you know, sometimes you don't remember and you messed up. Okay, so again, you got to have all that. Okay, so again, 1, 5, 0, negative 9, 6, right? Okay, divide. And again, remember, you have to take the opposite, right? The reason you have to take opposite is not only the easier to do, but also what you're doing is you're looking for the roots. If you solve for x, if you set this equal to 0 and solve for x, you're going to get x equal to what? Negative 2, right? If you solve. So that's where the negative 2 came from. So this is actually your root, okay? So you drop the number, multiply, you add, multiply, you add, multiply, you add, multiply, you add. Okay? So your answer would be, so it would be 0, 1, 2, 3. So it would be 1x cubed plus 3x squared minus 6x plus 3 plus 12 over x plus 2. And that's your answer. Oh wait, did I this? Oh, I'm sorry. No. Sorry. Yeah, you have to be careful. Right, negative 2 times 3 is negative 6. So remainder is 0. So that's your answer. Okay? So again, you see it's much easier to do than doing a long division, right? Okay, let's do example 2. Okay, so you have, now when you're doing the homework, you don't have to copy down the problem, right? You can just go and write down the coefficient already. So you're going to have a 6. Then you're going to get 1. You're going to get 13. You're going to get 12, right? Okay, and you, okay, we have a problem with here. Back up. Okay, so you have 6x cubed plus x squared plus 13x plus 12 divided by 3x plus 2. Okay, I'm going to need more space. I'm going to do it on this one. Back up. Okay, page 345, example 2. So you have this problem, okay? Now, notice what I said, remember what I said about synthetic deviation, right? You cannot have a number in front of the x. So if you have number in front, you cannot use synthetic deviation. So now what? Well, if you cannot, then you have to get rid of the 3, right? So let's go ahead and factor out the 3 from the bottom. So that's going to factor out factor out the 1 from the top, factor out the 3 from the bottom. Okay? So don't do anything to the top basically. So when you factor out the 3, you're going to get x plus 2 over 3. And you can check, right? See over here? You just go and cover these things up and then, just check, right? 3 times x give you 3x, right? 3 times 2/3 give you 2, right? So basically you factor out the 3. And always double check. So now you can focus on this part over here when you're doing the synthetic deviation. So you're going to have a 6, 1, 13, 12, and you have to take the opposite, right? So negative 2 over 3. Okay? So now you drop, you multiply, you add, you multiply, this cancels out, so you're going to get positive 2. You add, you get 15. You multiply, you're going to get negative 10. And double check, and you add, you're going to get 2. Okay? Okay, so now, from here, right? From this part over here, okay, you keep the 1/3 in front. So from this part, when you divide, you're going to get 6x squared minus 3x plus 15 plus 2 over x plus 2 over 3, right? From this part, just this part alone, right? The denominator does not change, right? So once you get this part, now all you have to do is just multiply the 1/3 by gain. Okay, that's what they do. So basically, first you get rid of 3 and you multiply by gain. So you have to distribute. So this will give you 2x squared. Multiply, you're going to get negative x. Multiply, you're going to get plus 5. And when you multiply this, you're going to get plus 2 over 3x plus 2. So you're going to get back your original denominator. Okay, and that's your answer. Okay, so again, when you have this kind of situation, you just do that. Okay. Okay, so let's go ahead and practice.